Okay. What will happen if we will get the square of these numbers? For example, we get the square of 1. What is the square of 1? That means 1 times 1 equals 1. If we have 2 raised to the power of 2, that means 2 times 2 equals 4. How about 3? 3 raised to the power of 2 is equal to 3 times 3 equals 9. Next, we have 4 square. That is 4 times 4 equals 16. We get the square of 5. That is 5 times 5 is equal to 25. Square of 6. That is 6 times 6 equals 36. 7 square. That is 7 times 7 equals 49. 8 square is equal to 8 times 8 equals 64. 9 square. That is 9 times 9 equals 81. Then if we have 10 square, that is 10 times 10 equals 100. Now, what do we call those numbers? After getting the square of numbers 1 to 10, we arrive with the following numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. How do we call those numbers? We call those numbers as perfect square. Those numbers are perfect square numbers. Now, how about if we are asked to get the square root of perfect square numbers? What is the answer? For example, what is the square root of a perfect square number 1? Square root of 1. That is 1. Okay? By the way, what's the difference between these expressions? X equals the square root of 2, or x squared equals 2. What's the difference? In here, for example 1, x equals positive square root of 2. Why positive? Because the square root sign is already written. Unlike in here, if we are asked to determine the value of x, we still need to extract the square root of both sides. So we have to indicate positive or negative. X is equal to positive or negative square root of 2. So that is the difference when the radical sign is already indicated, or when the radical sign is not yet indicated. Now, going back here, what is the square root of 4? That is 2. What is the square root of 9? That is 3. What is the square root of 16? That is 4. What is the square root of 25? That is 5. What is the square root of 36? That is 6. Square root of 49? That is 7. Square root of 64? That is 8. Square root of 81? That is 9. And the square root of 100 is 10. See? Take note of the relationship, no? We started from 1 here. We get the square of 1. We perform the exponent 2. That means 1 times 1. And that is equal to 1. That is a perfect square. Now, let's say we would like to determine the square root of 1 as a perfect square. And each square root is 1. Let's proceed to number 2. We get the square of number 2 through applying the concept of the exponent, meaning we need to multiply the base to itself twice, and the result is 4. 4 is a perfect square. Getting the square root of a perfect square number is 2. Okay? And up to square root of 100, that is 10. Okay? We can continue it, but in this case we just considered numbers 1 to 10. Now let's consider 18. The question is 18 a perfect square number? Is it a perfect square number? By looking on this one, 18 is lying between 16, perfect square number 16, and perfect square number 25. So 18 is not a perfect square. But how to extract the square root of a perfect of a non-perfect square number? That the answer should not be in decimal, meaning we do not need to use calculator. So what we can do to extract the square root of 18, the square root of 18, we have to factor 18. We have to get the factors of 18. Our goal is to identify factors of 18 which are perfect square. We know that 18 is also equal to 9 times 2. So as you can see, 9 is a perfect square. 2 is not a perfect square. Simplifying it, we have the square root of 3 square times 2. 9 is equivalent to 3 square. Equals, since the exponent here is 2 and the index is 2, we can cancel it. And we can write 3 outside of the radical. Then our radicand is 2. And the final answer is 3 is square root of 2. Take note that instead of using instead of using decimal numbers, we allow that the final answer be expressed into radical form. 3 is square root of